Hi dear students, in this question there are two parts. To the first part, it's asked that deduce an expression for the frequency of revolution of a charged particle in a magnetic field and show that it is independent of velocity or energy of the particle. So we need to know that the force that a charge q will experience in a magnetic field when it is moving with a velocity vector v, so the force will be equal to this. So we already know that the force is equals to q into v cross b. So this force will provide the centripetal acceleration, as we know that due to this it will move in a circular motion, and that is why we are being asked to find the frequency of that rotation or revolution. So for that condition we can write that the centripetal force for that charge should be equal to the force due to the magnetic field or the Lorentz force. So now let's write this as mv square by r, where m is the mass of the charge and r is the radius of curvature in which of the circle in which it is moving in the magnetic field, will be equal to qvb. Now, why have I written QVB? I am assuming that V and B have an angle of 90 degrees between them. So here the V and V gets cancelled. So I get the radius as MV upon QB. So this is the radius in which it will perform circular motion. So now because I have found the radius, and radius V is equals to r omega, we know for a circular motion V is equals to r omega. So using this using the two expressions we can find that omega is equals to V by r, and V by r we can obtain from this equation. So V by r will be equal to QB by m. So if we have the angular speed, we can find the time period. Now time period will be nothing but time period of one rotation would be 2 pi by omega. Now 2 pi by omega will give us 2 pi m upon qb. Now this is the time period. Now we can see that the time period of this circular motion is independent of the energy of the particle or the velocity. So it doesn't have the velocity term. So if the time period is independent, the reciprocal of time period is the frequency. The frequency, we can say frequency of the revolution is qb upon 2 pi m. So from here we have established that the frequency is independent of velocity. Frequency of revolution is independent of velocity. So these simple steps give us the answer to this question, the first part, and this is how we answered this question, by actually finding it out and establishing that it is independent of velocity. Now in the second part we have been asked to draw a schematic sketch of a cyclotron. Now cyclotron is a device which we will discuss in detail. Explain giving essential details of its construction and how is it used to accelerate the charged particles. Now we will see that this application that we have found out in the part A, that this frequency is independent of the velocity. The same application drives the concept of a cyclotron. So let's have a look. So this is a schematic diagram of a cyclotron, and I'll tell you what is happening. Here the magnetic field is coming out of the paper, that is coming out of the screen, and we leave a proton over here. And what happens is, as we leave the proton gets attracted towards the left part. Now this is a D, and this is there are two D's, and they are connected with an oscillator, and this oscillator keeps changing the polarity between the two D's. So initially, because as the proton is getting attracted towards the left D, we can say it is a positive charge, so electric field is in this direction. So that means polarity is something like this is positive and this is negative. So because of that, the proton gets attracted towards the left D, and obviously as it possesses some velocity, it is now in circular motion because of the magnetic force, that is QVB, and because of that it tries to complete the circle, and as soon as it comes between the two D's, again the polarity due to the oscillator changes because it is matching with the frequency at which it is doing circular motion, and because of which here the polarity was like this. When the proton has reached here, the magnetic electric field changes its direction because of the change in polarity. Then this becomes positive and this becomes negative. Then because of this QE force, this provides the acceleration. So each time the proton comes between the two D's, it gets accelerated because of QE force. So QE by m would be the acceleration. So this is the part where it is getting accelerated again and again. And because it is getting accelerated, the radius that we had found r was equals to mv by qb. So we can say m, q and v will remain constant, and because of acceleration, velocity will increase, because of which the radius of curvature will also increase. So that is why the radius is continuously increasing each time it is accelerated in this gap between the two D's. The velocity increases, because of which the radius increases. So that is why it is a spiral. The way in which the proton is moving is a spiral, is a spiral, because the radius is continuously increasing because of the acceleration. And this is actually a device which is used to, and what it is doing, it is we can see that it is accelerating a charged particle, and that is exactly what a cyclotron does. It is used to accelerate the charged particles or ions to high energy using electric field and magnetic field. Both are used in a cyclotron. Now one thing that we should know is that magnetic field remains constant, but electric field keeps changing its direction in order to accelerate the charged particles. So that is the simple working of a cyclotron device. And here you get your proton. Here your proton did not have any energy, but now when it reaches this part, it has a lot of energy to go forward. So now this was the working of a cyclotron, and what we really need to know here is something that is extremely important, is that here this will only happen if the frequency of the oscillator is in resonance with the frequency of the particle or of the charge when it is doing the revolution. So that resonance condition is a must. So we need to mention that also. So that resonance condition should be there. So only then will a cyclotron work properly. So we can say that frequency of oscillator here should be equal to the same QB upon 2 pi m, as we had discussed in the previous example. Here QB upon 2 pi m, the same frequency the oscillator should have. So the time period, similarly we can find the time period, because we know the frequency. We can say the time period of the oscillation would be 1 upon frequency of oscillation, which would be nothing but 2 pi m upon qb. So we can say for the proton of charge q and mass m, the q and m are fixed. Q and m are fixed, and because the q and m are fixed, the oscillator we assumed is designed to work on a single fixed frequency of s, that is f oscillation here, and it is independent of the radius also. Even if the radius keeps increasing, the frequency is not affected. And because radius and velocities are, because if the radius increases, that means the velocity has increased, but that doesn't affect the frequency in any manner. So that will be the answer to our question. At the end, we can also say that the kinetic energy of the charged particle can be written as, take you to the next page. We can also give an add-on here, that kinetic energy, because we were talking about velocity and energy also. So kinetic energy is nothing but, because we know the velocity, so we can write half mv square. Now from the previous relation, we had established that mv square by r is equals to qvb. So we had got the velocity as qbr upon m. So same velocity we can substitute in this kinetic energy, and we can get half q square b square r square upon m.